Welcome to GoClasses. Let's start now. So complete graph theory we will cover with gate PYQs, gate questions. Okay. So let's start this revision. The first topic is what is graph? What is graph in graph theory? In school life, you have seen this type of graph. This type of graph you have seen in the school. This type of graph you have seen. This type of graph you have seen. But these are not the graph we study in the graph theory. Okay. These are not graph. These are called plots. Okay. So remember, these type of graphs we don't study. These are called plots. These are called plots. Okay. So if you see, these are called plots. Basically, you are plotting the data. So these are called plots. These are not the graph. Okay. So what is a graph then? Now you might be thinking, so what is a graph then? So graph is basically very simple. Graph is just some dots and lines. So you can see some dots and some lines. So what is a graph? Let me tell you, graph is nothing but some dots and some lines. So for example, you can see there are some dots which are connected by some lines. Okay, like these are the dots. This is a dot, this is a dot, and this is connected by a line. This is a line. Okay, so you can easily see like another example. For example, this is a dot, this is a dot, and this is connected by this line. Okay, so graph, what is a graph? Graph is basically there are some dots and these are connected by some lines. So this is a graph. Now, so you can see what is the simplest definition of graph. If anyone asks you what is the simplest informal definition, remember this is the informal definition. So the simplest definition is there are some dots or some nodes and there are some lines which are connecting these dots. Okay, some dots are there, these are the dots, and there are some lines which are connecting these dots. Okay, for example, I can say this is a graph. I can say this is a graph. You can consider this is a graph. Okay, let's call it graph G. So this is your graph G. Okay, now let's move on. So you can notice this is a graph. You can see some nodes and some lines connecting them, some dots and some lines connecting them, some dots and some lines connecting them. Now you might be thinking, why study dots and lines? What is the importance of dots and lines, right? Yes or no? Okay, so what is the reason? Like just think about it. Why we want to study dots and lines? For example, this type of dots and this type of lines, why we want to study? What is the purpose? What we will get? What mathematicians, why they are so obsessed about these dots and lines? Okay, so if anyone asks you, like you might be thinking, sir, what is the reason all these mathematicians are obsessed with dots and lines? Why we study graph? Okay, so the answer is very simple. Let me tell you, the answer is very simple because it is in the syllabus. Okay, this is the simple answer, because if it is not in the syllabus, you will never study this. Whatever applications it has, you don't care. If it is not in the syllabus, you will not study this. So why we study graph theory? Because it is in the syllabus. Okay, so seriously, now you might be thinking, sir, tell me why we study graph. Okay, so the answer is very simple, because graph is a simple representation of reality. Okay, so what is a graph? Remember, graph is representation of reality. Graph is simple representation of reality. This is the simplest definition. In any interview, if they ask you what is a graph, in any interview, then you can impress the interviewer and you can say that graph is a simple representation. The graph is nothing but a representation of reality. Okay, so for example, look at this. This is a chemical, some chemical structure in front of you. Okay, so if you want to study the properties of this chemical structure, what you can do? This is the chemical structure. You want to study the properties of this chemical structure, then what you can do? You can draw, you can convert this chemical structure into dots and lines. Okay, so like this. Okay, like this you can create some dots. Okay, so like this, you can create some dots and then you can connect them with lines. Okay, so you can see that if you want to study the properties of this structure, okay, if you want to study the properties of this structure, then what you can do? You can convert it into a graph and then you can simply, now you can notice this is the structure, this is the reality. Remember, this is the reality, right? Yes or no? This is the reality, but this is, what is this? This is just a representation, right? Correct or not? Yes or no? You can see this is just a representation of reality. This is just a representation of, so I can say this is just a representation of reality, correct? So remember, the reality that you have, this is the reality. Okay, this reality you are representing using a graph. So this is representation of reality. If anyone asks you, what is a graph? Graph is simple representation of reality. Now, if you want to study the property of this chemical structure, then what you can do? You can study this graph. Yes or no? Okay, agree or not? So you tell me, simple question I am asking. Okay, which of these is easy to study? Like if you want to study this chemical structure, or if you want to study this graph, which is easy to study? So you can easily say that this structure is easy to study. We can easily study this, and then automatically we will get insight about this. Yes or no? So once you study this graph, once you study this simple structure, once you study this representation, then you will get insight, you will get knowledge about this reality, you will get knowledge about this chemical structure. Okay, so this is the simple idea. This is what I am saying. Okay, now let's move on. So for example, like flow chart, like this also you can convert into a graph. You will get a directed graph here. Yes or no? In this is your flow chart. If you want to study the property of this flow chart, then what you will get? Then you will get a directed graph. Okay, then in this situation you are going to get a directed graph. This type of directed graph you are going to get. Okay, so if you want to study the properties of this flow chart, then you can study the properties of this graph. This is reality and this is a representation of reality. Now similarly you can notice this is a reality and you can study the properties of this structure. This is some structure, okay, in your body or whatever is this structure. If you want to study the properties of this structure, then you can convert this structure into a graph, into some dots and lines. Okay, you can convert this structure, this reality. Remember, this is reality. Okay, can I say this is your reality? And this reality you can convert into some dots and lines, and then you can study these dots and lines. Okay, so if you want knowledge about this reality, then you can study this graph, so that once you study this graph, then you will get knowledge about this reality. Okay, so very simple. Similarly, for example, Facebook. If you want to study about Facebook, if you want to create Facebook, then you need to know graph theory. Okay, similarly, Google. Okay, so all these structures, for example, this is the universe. If you want to study the universe, then again you can convert this universe into a graph, and then you can study that graph. So finally, what is common in all these structures? All these complex structures that we have seen, many complicated structures I showed you. Now what is common? What is common in all these structures? You can see there are some dots and some lines. Yes or no? There is some set of objects and some links between them. So this is the simple point. If anyone asks you what is a graph, then what you will say? You will say that graph is abstraction of reality. Yes or no? What is graph? Graph is abstraction of reality. Graph is representation of reality. We want to study reality, then what you can do? You can convert this reality into a graph, and then you can study the graph. Okay, so this is the idea. So finally I can say, what is a graph? Graph is abstraction of reality. So what you can do, if you have some real life problem, some real world problem you can convert this problem into a graph. You can study this graph, and then you can solve this problem. Okay, so very easily. So you can notice we use graph to solve real world problems. Okay, your real life problems you can solve by converting those problems into a graph. Okay, very easily. So this is the final point. So I can say graph are tools to solve problems. Yes or no? Graphs, these are tools to solve problems. You can convert your problem into a graph. This problem you can convert into a graph, and then you can solve this problem by solving this graph. Okay, by studying this graph. Okay, so this is the complete purpose of graph, why we study dots and lines. So now, okay, now can you tell me that dots and lines are very important? Tell me. Now, are you convinced that dots and lines are very important? Yes or no? So this graph, what is a graph? We have already seen graph. What is a graph? Graph is just some dots and lines. Okay, some dots are there, some nodes are there, and these are connected by lines. These are connected by lines. So you can see this is a graph. So you can see this is a graph, and why we study graph. Is that clear to you? Okay, now let's see. Now let's see this one. Now let's see this. So you can see the next is graph definition. What is graph definition? So graph definition is very simple. That is basically a graph is a mathematical structure. Okay, a graph is a mathematical structure in which we represent relationship between objects. Okay, so basically some set of vertices, like these are the nodes. For example, this is a node. Okay, and this is a edge. This is a link, and this is a edge. So finally you can say that a graph is basically some set of nodes, or I can say vertices, some set of vertices, and these are connected by edges. Okay, so these some set of vertices, these are connected by edges. This is a graph. So this is your definition of graph. Now let's see. So you can see these are the nodes, these are the vertices, and these are connected by edges, you can notice. Okay, yes or no? So these are the nodes, total 5 nodes you have, and these 5 nodes are connected by edges. These are the edges, these are the links. Okay, this is the definition of graph. Now the graph can be directed also. For example, look at this graph. In this graph you have direction, so I can say from this node, from this vertex to this vertex, there is a direction. So this edge has a direction, so you can see this edge has a direction. Look at this edge also has a direction, this edge also has a direction. So every edge has a direction, so this is a directed graph. Similarly, graph can be undirected also. Like for example, look at this edge has no direction. Look at this edge has no direction. So you can notice there is no edge which is directed. Okay, all the edges are undirected, no edge has direction. So this type of graph is undirected graph. So you can see directed graph means edges have direction. Okay, this is directed graph. Undirected graph means edges don't have direction. This is your undirected graph. Okay, let's move on. So finally, what is directed graph, what is undirected graph? So there are two type of graph. Okay, there are two type of graph. One graph is basically undirected graph, and another is directed graph. Another is a directed graph. So what is a directed graph, undirected graph? The undirected graph means the edges don't have direction. So in this undirected graph, what you have set of vertices. This is your set of vertices, like for example A, B, C, these are the set of vertices, and you have set of edges. Remember, in this, for example, these are the vertices like A, B, C, these are the vertices. And you can notice edges don't have direction. So for example, look at this graph. This graph is undirected graph because edges don't have direction. So you can see that this edge is nothing but a set A, B. Okay, because this edge is undirected. I can say there is no direction. Okay, so this edge is basically unordered pair of these two vertices. Okay, similarly, this edge is basically nothing but A, C. So you can see the set of edges is basically, I can say, in this you have unordered pairs. In this you have unordered pairs. So every edge is unordered pair. This is edge, this is edge. Every edge is unordered pair. Okay, very easily you can see. Now let's see what is directed graph. The directed graph, the set of vertices is same. Like, okay, in this also you have set of vertices. Now what is set of edges? Now in this directed graph, what happens? Every edge has a direction. Okay, every edge has some direction. So for example, this is edge. Okay, look at this is edge. Okay, so for example, you can see this is edge. So every edge has a direction. Now I can say that this is a set of edges, but every edge is ordered pair. Like you can see, look at this. Look at this edge. Look at this edge. So this is from A to B. So this is an ordered pair. So this is from A to B. Similarly, look at this edge. This edge is from B to A. So this is an ordered pair from B to A. Look at this edge. This is from A to C. So this is from A to C. So this is the difference in undirected graph and directed graph. In the undirected graph, you have set of vertices and set of edges, but every edge is unordered pair of vertices. Unordered pair. Okay, because there is no direction in any edge. Every edge is basically unordered pair of vertices. In the directed graph, what happens? Every edge has a direction. So that is the reason I can say this edge, look at this edge, this is from A to B. This edge is from A to B. So I can say this is ordered pair A, B. This edge is from B to A. So this is ordered pair B, A. Okay, so the directed graph is basically set of edges, but every edge is ordered pair. So this is the difference between directed graph and undirected graph. In the directed graph, you don't have edges, you don't have direction, edges don't have direction, and in the directed graph, edges have direction. Okay, so this is the directed graph. You can see this is your directed graph and this is your undirected graph. Now let's move on. Okay, now let's see self loop. What is a self loop? So in the directed graph also you can have self loop. In the directed graph, what is your self loop? In the directed graph, for example, if vertex from this vertex to this vertex, if you have edge, this is called self loop. Okay, so you can see this is from A to A. This is called self loop. Okay, so this is called self loop, or you can simply call it loop. So you can simply call it loop, or you can call it self loop. This is your directed graph. Now what is undirected graph? In the undirected graph also you can have self loop. So for example, if you have this vertex, then this type of loop, look at this. Okay, so you can say this is your between A, A. So remember, in the directed graph, every age is ordered pair. In the undirected graph, every age is unordered pair. So here in the directed graph, because this is directed graph, so every age is ordered pair, ordered pair. In the undirected graph, every age is unordered pair. Okay, so this is your self loop. So you can call it self loop. Okay, now let me tell you one thing. Let me tell you one thing, that by default, when we talk about undirected graph, we don't consider self loop, but by default when we talk about directed graph, we consider self loop. So this is something like by default. Okay, like if you by default, or I can say generally, when you talk about directed graph, when you are talking about directed graph, then generally self loops are considered. Okay, then generally we consider self loop. Okay, so we also consider self loop. So self loops are generally considered when you talk about directed graph, then self loops are considered. Okay, like we don't ignore the possibility of self loop. We don't ignore the possibility of self loop. Okay, but in the undirected graph, generally by default, if no information is given to you, okay, if no information is given to you, then in undirected graph, by default, self loops are ignored, or I can say self loops are not considered. Okay, self loops are not considered. We don't consider self loops. We assume that self loops are not there. Okay, so this is something that when you talk about directed graph, then by default self loops are considered. We don't ignore the possibility of self loop, but remember, in the undirected graph, by default self loops are not considered. We ignore the possibility of self loop by default if no information is given to you. Okay, so this is what I want to say, that in the directed graph, okay, in the directed graph, self loops are generally allowed. Okay, unless some information is given to you, unless specified otherwise. Similarly, in the undirected graph, self loops are generally not allowed. Okay, unless they specify. So you can notice in the undirected graph, by default we don't consider self loop. In the directed graph, by default we consider self loop. Okay, so this is something. But anyway, most of the time we will not consider self loop. Most of the graph in the GATE exam, most of the questions that you will see, almost I can say 99.99% questions in the GATE exam don't consider self loop. There is no self loop. Okay, so you don't have to worry about self loop. Okay, so in the GATE exam, 99% questions, okay, more than 99% questions don't have self loops. Okay, they don't consider self loops. So don't worry about self loops. But if they give you some information about self loop, then you have to consider. Okay, so this is the point. Now let's move on. One thing also I want to tell you, that if there is age between u comma v, okay, so for example, if this is your vertex u, this is your vertex v, if there is age between vertex u comma v, like this is your age, then what we will say? Then we will say that e is incident on, I can say e is incident on u comma v. Okay, or I can say these are the endpoints of, so I can say u comma v are endpoints of e. Okay, so here you can notice this is undirected age. Okay, this age, if you see, this does not have any direction, so this is an unordered pair, u comma v. Okay, this is same as v comma u, right? Because this is unordered pair. But for simplicity we will write it uv, or you can write it vu. But for simplicity, this is just for simplicity. Okay, this is for simplicity. For simplicity we will write, but it does not mean that there is order. Okay, is this clear? For simplicity we will write uv. Okay, you already know the graph is undirected. If the graph is undirected, then there is no ambiguity. Yes or no? There is no ambiguity if the graph is undirected. Your graph is undirected, then there is no ambiguity. Okay, because it simply means that this is your age uv. Okay, so this is for simplicity only. This is the simple reason. So you can see, for notational convenience, only for simplicity, if you already know that graph is undirected, then you can write this age as AB. Okay, for simplicity, so that you don't have to write this again and again. Okay, so this is the point. And similarly, if you have age between u comma v, then we will say that E is incident to u comma v. Or I can say u comma v are the endpoints of E. Now let's move on. Now let me tell you one thing. What is a simple graph? Because this is very important. Okay, in the GATE exam, or I can say most of the time, 99% of the time we study only, or I can say 99% of the time, okay, 99% time we study only simple graph. we study only simple graph. Only simple graph. So simple graphs are very important, and these are the most important graph, because most of the time we only study simple graph. What is a simple graph? Simple graph is undirected. Simple graph is undirected. No self loop. There is no self loop. Okay, there is no self loop, and there is no multiple edges. Now let me explain what is multiple edges. There is no self loop and there is no multiple edges. Now, so let me explain what is multiple edges. What are multiple edges? What are multiple edges? So you can see that multiple edges, these are also called parallel edges. These are also called parallel edges. So what are multiple edges or parallel edges? Now these multiple edges in the directed graph. So let's see. First, let's see for the directed graph. In okay, undirected and directed graph, both of them we will see. In the directed graph. Okay, so let's see. First, let's see for undirected graph. In undirected graph, what is a multiple edges? Multiple edges, or I can say parallel edges. What are these? These are edges like this. You have two vertices, and between two vertices, you have multiple edges. Okay, so you can see these are multiple edges. These are called parallel edges, or I can say multiple edges. So you can see these are your multiple edges. You can call them multi edges, or I can say multiple edges, or I can say these are the parallel edges. Okay, so you can notice between the same vertices. So for example, this edge is also AB. This edge is also between AB. This edge is also between AB. So these are the same edges. I can say parallel edges, multiple edges. These are basically the same edges. I can say same edges. These are basically the same edges. Like the same edges. Like for example, look at this. This is also AB. So all these edges are same. Yes or no? Between two vertices, between A comma B, these three edges, if you look, these are same edges. These are same edges. So multiple edges means same edges. So these are called multiple edges, or I can say parallel edges, or I can say multi-edge. In the directed graph, what will happen? In the directed graph, you tell me a simple question I am asking. In the directed graph, can I say these are multiple edges? Look at this edge E1, look at this edge E2. Are these multiple edges? Tell me, in this graph, are these multiple edges? Let me know. Okay, so tell me, are these multiple edges? No, these are not multiple edges, because remember, this even is from A to B. This is from A to B, and this is from B to A. These are not multiple edges. So remember, these are not multi-edges. These are not multi-edges. These are not parallel edges. Remember, these are not parallel edges. Okay, so these are not parallel edges. Don't say that these are parallel edges. These are not parallel edges, because this is from A to B, this is from B to A. These are not parallel edges. Then what are parallel edges in directed graph? In the directed graph, parallel edges are like this. Okay, the parallel edges are like this. For example, this is also from A to B, this is also from A to B. These are the parallel edges. Okay, so you can see both of them are from A to B. Both of them from A to B. This is also from A to B. This is also from A to B. Now these are parallel edges. These are multiple edges. Okay, so this is the difference. Now let me tell you what is a simple graph. Simple graph simply means that it is undirected graph. There is no self loop. There is no multiple edges. Okay, so this is your graph. This type of graph is called simple graph. Let me tell you, all the graphs that we will study are simple graph unless I mention otherwise. Okay, so if I don't mention anything, then we are talking about simple graph. Is this clear? Let me know. If we do not mention anything, if I do not tell you anything about the graph, then it simply means it is a simple graph. It simply means it is an undirected graph without self loops, without multiple edges. So remember, if no information is given to you about the graph, if they simply say graph, then it automatically means that it is a simple graph. It is undirected, no self loops, no multiple edges. Okay, so very simple. So this is your simple graph. This type of graph is called simple graph. Okay, now let's move on. So remember, going forward, we will discuss about simple graph. We will discuss about undirected graph. By default, all the graph that we study, by default, when I tell you about the graph, then it simply means this term, or simply means simple graph. Simple graph means undirected graph. This is by default. Okay, so by default, it simply means simple graph. Simple graph means undirected. Remember, simple graph means undirected, no self loops, no multi-edges. Okay, now let's move on. Now let's see graph terminology. So the next terminology is adjacency. What is adjacency? When can I say two vertices are adjacent? So look at this. Two vertices are adjacent if they are connected by edge. If there is edge between them, then we will say that they are adjacent. Okay, so it's like neighbors. Okay, for example, this is your house, this is your house, and this is your these are connected by wall. Yes or no? These are connected by this wall. So you can simply see that if they are connected by this wall, so in this situation these will be called adjacent. Okay, so in this situation we will say that these are adjacent. Adjacent means they have edge between them. They are directly connected by edge. So this is called adjacency. Now you tell me, how many adjacent vertices this CAT has? This vertex has how many neighbors? Let me tell you, adjacent means neighbors also. Okay, so this adjacent, this also means neighbors. Neighbor. So tell me, how many neighbors are there? How many neighbors of CAT? So you can notice total how many neighbors are there. You can easily see this is a neighbor, this is a neighbor, this is a neighbor, and this is a neighbor, because there is edge. Because there are 4 edges, so there are 4 neighbors. So this vertex has total 4 neighbors. You can see. Okay. You can see these two are not neighbors, because this vertex and this vertex, they do not have any edge between them. Similarly, this vertex and this vertex, they do not have any edge between them. So you can notice this vertex has total 4 neighbors. This vertex has total 4 neighbors. These are the neighbors of CAT. Okay, so very simple. So you can see two vertices are adjacent if there is edge between them. This is called adjacency. Now similarly, edges are also adjacent. So let me tell you adjacent edges. When can you say adjacent edges? Adjacent edges, like two edges, when can you say adjacent? So you can easily see, like for example, if you have this graph, in this graph A, B, C, D, you can see that, look at this edge E1, E2. Okay, let me give you E1, E2, E3, E4. Consider these two edges. So you can notice E1, E2, they are neighbors, right? Yes or no? Look at this edge E2, this edge E2 you see, and this edge E1 you see. So these are basically neighbors, right? Because they have a common endpoint. So easily I can say that E1, E2 are neighbors. They are neighbors, or I can say adjacent. They are adjacent, or I can say they are neighbors. Why? Because there is edge between them. Now similarly, you can notice that this E2 and E4, okay, why they are adjacent edges? Adjacent edges, it simply means having common endpoint. Okay, so they have common endpoint. They have common endpoint. They have a common endpoint, then we will say that these are adjacent edges. For example, E3 and E4, they are adjacent edges. Look at this E3, and this E4. Okay, they have a common endpoint, so that is the reason these are also adjacent. Okay, now but you can notice that E3, E1, these are not adjacent. Look at this E3, look at this E3, this E1, they do not have any common endpoint. So you can note this is like AC, this is your BD, so they do not have any common endpoint. There is no common endpoint, so that is the reason these are not adjacent. Okay, so these are not neighbors. Okay, very simple. Now let's see the next. The next concept is degree. What is degree? Degree of a vertex. Degree of a vertex. Remember, I am talking about simple graph. We are discussing undirected graph. So this degree concept is only for undirected graph. Again, I am telling you, we are discussing undirected graph. So this concept, which concept? This degree concept. This concept is only defined for undirected graph. Only defined. This concept is only defined for undirected graph. Of course, in some other way you can define it for anything. Okay, if you want to define, but like by default when we hear the word degree, this is only defined for undirected graph. So in an undirected graph, what is degree of a vertex? Degree of a vertex is how many edges are incident on it. Very simple. Okay, so degree of a vertex in undirected graph is the number of edges incident with it. Okay, how many edges are incident? For example, look at this vertex. Now consider this vertex. Now let's assume this is edge, this is another edge, this is another edge, and let's assume this is a self loop. So now you can notice how many edges are incident on this A. How many edges are incident on this A? that is the degree of A. So for this vertex A, what is the degree of A? That will be this edge, this edge, this edge. But this self loop we will count 2 times. So the answer will be 3 plus 2, that will be 5. Remember, this self loop we count 2 times when we calculate degree of a vertex. Okay, why? What is the reason? Because you can consider this as AA. So you can notice this is incident on A 2 times. Okay, this is incident, this self loop, look at this self loop, this is incident on A 2 times. This is falling on A 2 times. You can consider like this. This is falling on A 2 times. You can consider like this. So that is the reason answer is 5. Okay. So you can see that when you calculate degree of a vertex, then this self loop will be counted 2 times very easily. If you have this vertex, consider this vertex. Consider this vertex. Now, what is the degree of this vertex? Look at this. Now the degree of this vertex will be, you can see that the degree of this vertex will be, answer will be 6. So here the degree of this vertex B, that will be 6. Okay, so this is the concept of degree. So when you calculate degree of a vertex, then this self loop is counted 2 times. Okay, the reason is very simple, because look at this self loop. This self loop is falling on B 2 times. Okay, this is falling on B 2 times. So that is the reason when you calculate degree of a vertex, then that self loop is counted 2 times. Okay, this is the degree of B is equal to 6. So this is your point. What is the degree? Now similarly, you have maximum degree, minimum degree. In a graph, you can calculate what in a graph. You can find out what is the maximum vertex degree, what is minimum vertex degree. Okay, so very simple. Let me tell you what is maximum degree in a graph. You have a graph G. So let's assume you have a graph G. In this graph G, what is maximum degree? What is maximum degree? Maximum degree is like among all the degrees you find maximum. Okay, you find maximum of all degrees. Okay, just find the maximum among all the degrees. Okay, so among all the degrees you find the maximum of all degrees. Similarly, what is minimum degree? What is minimum degree of this graph? That will be minimum of all degrees. Similarly, you can find average degree. Okay, that will be average of all degrees. Okay, so that is going to be average of all degrees. This maximum degree we denote by delta. Okay, so this is denoted normally by delta, this maximum degree. Okay, so this maximum degree we normally, this is denoted by delta, capital delta. And this minimum degree we denote by small delta. Okay, so like this. Now this is your maximum degree, minimum degree, average degree. Now let me tell you one more thing, that if a vertex has degree 0, vertex with degree 0, that is called isolated vertex. So this is the definition of isolated vertex. This is a vertex with degree 0. Okay, and what is pendant vertex? Pendant vertex, this is vertex with degree 1. Vertex whose degree is 1. Okay, so similarly, odd degree vertex, even degree vertex. Tell me what is odd degree vertex? The name itself is telling you what is odd degree vertex. Odd degree vertex means vertex with odd degree. Very simple. Okay, vertex who has odd degree. Vertex with odd degree. Similarly, there is something called even degree vertex. What is even degree vertex? Even degree vertex means vertex with even degree. Okay, so these are the simple definitions. Very simple definitions. Okay, so these are all the definitions that we have. So what is the degree? What is isolated vertex? What is pendant vertex? What is maximum degree of a graph? What is minimum degree of a graph? Okay, so this is the complete definition. Now let's see this example. Consider, and before we move on, let me also tell you what is order of a graph. Order of a graph is the number of vertices. Okay, so remember, if for any graph these two things are there, for any graph there is something called order and there is something called size. These are not standard terminology, but anyway you can just like remember them. Okay, so there is order of a graph, there is size of a graph. What is order of a graph? This is the size, this is the number of vertices, And what is size? This is the number of edges. Very simple. Okay, so you have a graph G, then the order is denoted like this, and size is denoted like this. Okay, so remember, this means number of edges, and this means number of vertices. Okay, is this clear? So is this point clear? You have any graph, for example, whatever, like consider this graph A, B, C. Okay, consider this graph. Now in this graph, what is the order of this order of, this is your graph G. Then what is the order? This simply means order of G. That is nothing but cardinality of vertex set. How many vertices are there? So there are 2 vertices. Okay, sorry, 3 vertices. There are 3 vertices. Now similarly, what is size of a graph? This is called size of a graph, size of G. And that is your number of edges. How many edges are there? There are 2 edges. Anyway, these are not standard terminology. Let me tell you, these terminology are not standard. But if by chance, by any chance, if they give you in the question, if they give you size of a graph, order of a graph, if they mention this, then you can easily see. Okay, so very easily you can see what is order. Order of a graph is cardinality of vertex set. How many vertices are there? That is the order of a graph. And size of a graph is means how many edges are there. Okay, order of a graph, size of a graph. Very simple. Now let's see the another concept, that is degree sequence. What is degree sequence? This concept, degree sequence is basically sequence of degrees. Okay, by default we write this in the decreasing order. Okay, so what is degree sequence? Degree sequence is basically, that is your, I can say, sequence of degrees, sequence of vertex degrees. By default we write it in the descending order. Like for example, if I give you this graph A, B, C, D, consider this graph, then what is the degree sequence for this graph? For this graph, what is the degree sequence? The degree sequence for this graph, what is that? You can notice this vertex has degree 3, this vertex has degree 2, this vertex has degree 3, this vertex has degree 2. This vertex has degree 2 because there are 2 edges incident on it. Okay, there are 2 edges incident on it. This vertex has degree 3 because there are 3 edges incident on it. Okay, similarly this vertex has degree 2 because there are 2 edges incident on it. This vertex has degree 3 because there are 3 edges incident on it. So the degree sequence will be 3, 3, 2, 2. By default we write it in the decreasing order. As I told you, by default usually we write this in the decreasing order. Okay, so this is how we write the degree sequence. This will be your degree sequence 3, 3, 2, 2. Now let's move on. So now just for your practice, look at this graph and tell me. You can notice this vertex has degree 0 because this is isolated vertex. So that is the reason. Look at this vertex. This is called isolated vertex because it has degree 0. This is a isolated vertex because it has degree 0. This vertex has degree 2 because there are 2 edges incident on it. This vertex has degree 5 because self loop is counted 2 times. When you calculate degree, then self loop is counted 2 times. So you can notice this vertex has degree 5. This vertex has degree 3. Similarly, you can notice this vertex has degree 3. Okay, so and so on. This is your pendant vertex. This is called pendant vertex because it has degree 1. Now you tell me what is the maximum degree of this graph. Can you tell me? In this graph, what is the maximum degree? The maximum degree is 3. Okay, the maximum degree in this graph, the maximum degree is 3. The minimum degree in this graph is 0. Okay. What is the number of edges? Can you tell me what is the number of edges? How many edges are there? So you can notice 1, 2, 3, 4, 5, 6, 7, 8. Total 8 edges are there. Can you tell me what is the degree sequence of this graph? Sorry, the maximum degree is 5. Sorry, in this graph, the maximum degree is 5. In this graph, the maximum degree is 5. The minimum degree is 0. Number of edges, you can see, number of edges will be so that will be 8. What is the degree sequence? What will be the degree sequence of this graph? The degree sequence of this graph will be very easily 5, 3, 3, 5, 3, 3, then 2, 2, then 1, 0. This will be the degree sequence of this graph. Okay, this is going to be the degree sequence. Now, what else? So can you tell me what is the summation of all degrees? In this graph, can you tell me summation of all degrees? Okay, so summation of all degrees, can you tell me what is that? Summation of all degrees. Like that is called total degree. That is called total degree. This is called total degree. So what is summation of all degrees? That is called total degree. Total degree means just do the summation of all degrees. Okay, that is your summation of all degrees for every vertex. Okay, so summation of all degrees, that will be like, that will be 5 plus 3 plus 3 plus 2 plus 2 plus 1 plus 0. Okay, and you can calculate. Okay, just do the summation of all these. So that is going to be 16. Is it a coincidence that this is equal to twice the number of edges? Can you notice this is twice the number of edges? Number of edges is 8. Number of edges is 8. And the total degree is, look at the total degree. Look at the total degree, that is 16. Number of edges is 8. Total degree is 16. Can you notice that total degree is equal to twice the number of edges? That is not a coincidence, let me tell you. That will always happen. So this is your most important result. Very important result. Many questions in the GATE exam on this result. Okay, there are many questions. So what is degree summation formula? What is this degree summation formula? This says that if you have an undirected graph, if you have any undirected graph you take, in any undirected graph, okay, in the undirected graph, what will happen? The total degree, or I can say summation of all degrees, the total degree will be equal to twice the number of edges. Okay, so I can say summation of all degrees, that is equal to twice the number of edges. That will always happen. What is the proof of this? So let me just quickly tell you the proof. The proof is very simple, that because of every edge, total degree increases by 2. Yes or no? Like for example, look at this graph. In this graph, you tell me a simple question I am asking. What is the summation of all degrees? In this graph, what is the summation of all degrees? Summation. Like this vertex has degree 1. This vertex has degree 4. This vertex has degree 3. This vertex has degree 3. This vertex has degree 3. Look at this vertex at degree 2. Okay, so these are your degrees. What is total degree? Look at the total degree. So total degree is basically, that is 16. So the total degree is 16. The answer will be 16. Total degree is 16. Can you notice number of edges will be 8? Number of edges will be 8 because total degree will be equal to twice the number of edges. So this total degree is twice the number of edges. So number of edges you can calculate, that will be 8. Number of edges you can calculate, number of edges is 8. Now why this is happening? What is the reason? Why? What is the reason? The reason is very simple. Because of every edge, like consider any undirected graph, consider this graph. Now because of every edge, total degree will increase by 2. Look at total degree. At this point of time, total degree is 0, right? Yes or no? So you can easily see that at this point of time, initially, what is your number of edges and what is total degree? You tell me about total degree. Okay, so slowly you tell me. Initially, you can notice, what is total degree? Initially, number of edges is 0, total degree is 0. Now tell me, if I do this, because of this edge, total degree will increase by 2. Yes or no? Because of this edge, this degree will increase by 1, this degree will increase by 1. Degree of A increase by 1, degree of B increase by 1, total degree will increase by 2. Okay, so because of this edge, total degree increasing by 2. Now similarly, because of this edge, look at because of this edge. Okay, so consider this edge. Because of this edge, this will increase by 1 and this will also increase by 1. So now you have 2 edges. There are 2 edges and the total degree now is 4. Now similarly, you can notice that. Now consider this edge. Now if I connect this edge, now you have 3 edges and the total degree is 6, because this will increase by 1, this will increase by 1. So easily you can notice. So finally I can say that because of every edge, whatever edge you put, like consider this edge. Now you have 4 edges and the total degree is 8. Why? Because this degree will increase by 1, this degree will increase by 1. So because of every edge, total degree increases by 1. Okay, because of every edge, remember. So each edge will give you, give a contribution of 2 in the total degree. So this is the point. I hope this point is clear. Okay, so this is very important result. Remember that total degree will be equal to twice the number of edges. Like consider this graph. In this graph you can check it out. Like what is the number of edges? Tell me what is the number of edges in this graph. Look at the number of edges. So that is like 1 2 3 4 5 6 7 8. So number of edges is 8. And what is total degree in this graph? You can calculate. Like this vertex has degree 2, this vertex has degree 4, this vertex has degree 3, this vertex has degree 4, this vertex has degree 4, this vertex has degree 1, this vertex has degree 0. So if you calculate this, then total will be 16. Yes or no? Or maybe. So this vertex has degree 4, this vertex has degree 4, 1, 3, 4. So I think number of edges is 9. Okay, calculate what is the number of edges. I think that will be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, total. Okay, so you can calculate that total degree is basically 18. Okay, so you can easily see that total degree is equal to twice the number of edges. That is twice the number of edges. Very simple. Now let's move on. Okay, similarly you can look at this graph. In this graph you have multi edges. That is also fine. This formula will always work for any undirected graph. Remember, for any undirected graph this will always work. Whether you have self loop, multi edges, does not matter. Whatever, if you have undirected graph, then this formula will always work. Okay, which formula? That total degree is equal to twice the number of edges. This will always work, because even if you have self loop, then it is also fine. Okay, because when you put self loop, then total degree will increase by 2. Yes or no? If you put this self loop, then total degree will increase by 2. Okay, similarly if you put this, then total degree will increase by 2. If you do this, total degree will increase by 2. So this formula will always work. Whether you have self loop, whether you have multi edges, this formula will always work, because of every edge total degree will increase by 2. Okay, like here in this graph also it will work. Okay, in this graph this has degree 1, this has degree, what is the degree? So degree will be 1 2 3 4 5 6. This has degree 6, this has degree total 5. Look at this has degree total 6. And what is the degree of this vertex? This vertex has degree 4. So you can easily notice that total degree in this graph, look at the total degree. The total degree is 22. And what is the number of edges in this graph? You can calculate the number of edges. 1 2 3 4 5 6 7 8 9 10 11. Okay, so you can notice that this formula will always work. Okay, let's move on now. Now the another important thing is how many odd degree vertices you can have. How many odd degree vertices you can have? Tell me. How many odd degree vertices we can have? How many odd degree vertices we can have? How many odd degree vertices we can have? Can you tell me? How many odd degree vertices you can have? A simple observation you should make. Can I say total degree is always even? Can I say total degree is always even, because that is twice the number of edges? So can I say total degree is always even? Total degree will always be even. So this is important, that total degree is always even. That total degree is always even. This is an important point, that total degree is always even. Okay, your total degree, that is always even. Now you tell me how many odd degree vertices you can have. The answer is very simple. Total degree must always be even. Okay, so for example, maybe you have this vertex which is even degree vertex. Maybe this has even degree. Maybe this has even degree. Maybe this has odd degree. Maybe this has odd degree. Maybe this has even degree. So you tell me, okay, like if you do even plus even, that will be even. Okay, so even plus even will always be even. Even plus even will always be even. Okay, so this will always be even. Even plus even will always be even. Even plus even will always be even. But this total must be even, right? And so on. This total this total must be even. So tell me how many odd degree vertices you can have. So how many odd degree vertices you can have? You should have even number of odd degree vertices, right? Yes or no? So you should have even number of odd degree vertices. Odd degree vertices. So how many odd degree vertices you can have? You can have even a number of odd degree vertices. In any graph, number of odd degree vertices should be even. So this is important. Any undirected graph must have even number of vertices with odd degree. Even number of vertices with odd degree. Okay, for example, whatever graph you create, A, B, C, D, whatever graph you create, like let me create a graph. You tell me at this point of time, what is the number of odd degree vertices? You tell me, a simple question I am asking. You tell me, what is the odd degree vertices at this point of time? At this point of time, initially at this point of time, how many odd degree vertices? Every vertex has degree 0. Yes or no? Every vertex has degree 0. So number of odd degree vertices, can you see that is even? Number of odd degree vertices is even. Okay, so you can easily see number of odd degree vertices. How many? Number of vertices with odd degree. Number of vertices with odd degree. Okay, number of vertices with odd degree. Number of vertices. So now if I do this, how many vertices have odd degree? There are 2. Okay, that is also even. If I do this, then how many vertices? Now you can notice that this is 2, this is 1. So now you can notice that again you have 2. Again you have 2. Whatever you do, okay, whatever you do. For example, if I do this, now this has degree 3, this has degree 1, this has degree 1. Again you have number of odd degree vertices is 4, and that is also even. So whatever you do, that will always be even. Okay, that will always be even. So very simple point, that even number of vertices of odd degree. How many vertices can have odd degree? How many odd degree vertices you can have? The answer will be even number of. Okay, yes or no? So whatever you do, you will always have even number of odd degree vertices. Whatever you do. Okay, let's move on. Now let's see some questions, some gate questions from all the concepts that we have seen so far. So far we have seen a lot of concepts. Now let me tell you, so far did you see all the concepts were easy? Yes or no? Do you agree that so far all the concepts that we have seen, these are very easy concepts? Directed graph, undirected graph, degree, maximum degree, minimum degree, average degree, degree sequence, isolated vertex. Okay, all the concepts that we have seen. Also degree summation formula, total degree is equal to twice the number of edges. Okay, so all the concepts that we have seen so far, do you agree these were very easy concepts? Yes or no? Very easy. You can understand them with proof. You don't have to by heart any concept. There is no rote learning. You can understand all the concepts very easily with proof. Now based on all these concepts, there are many questions in the GATE exam. Okay, many questions are in the GATE exam based on these concepts. So those questions we will solve. So actually first my target is to solve these questions. Okay, how many questions are there from these topics? Like counting related questions are 5 and degree related questions are 12. Total 17 questions. This is my target. First we will solve these 17 questions, then we will solve these questions. Okay, so our target, now let's see our target, our question type 1. What is question type 1? That is degree questions. Questions related to degree. This is your question type 1. This question we have already done, right? Yes or no? Show that this is your GATE 1987 question. Show that number of odd degree vertices is even. Number of odd degree vertices. How many odd degree vertices you can have in a finite graph? That will always be even. Yes, this is correct. We have already proven it. Okay, we have already proven it because the total degree must be even. Okay, the proof is very simple, that total degree must be even. And if the total degree must be even, then you can only have even number of odd degree vertices. The proof is very simple. The proof is very simple, that total degree must be even. Okay, this total degree, this must be even. So that is the reason this, how many odd degree vertices you can have, that should be even. Okay, So very simple. Now let's move on. This is another question, GATE 1995 question. Prove that in a finite graph, the number of vertices of odd degree is always even. Again the same question. Again the same question, that number of vertices of odd degree. How many vertices can have odd degree? That will be even. Okay. How many vertices can have odd degree? That is always even. This is another question in the GATE exam. Same concept. Now let's see this GATE question. This is GATE 2003 question. Can you solve it? GATE 2003 question. Can you try this question? Before you try this question, let me ask you some points. Let me ask you some points. Simple questions I am asking. You tell me, do you agree that, for example, let's assume that this is your total degree, means degree of, this is your summation of degree of all the vertices, right? Yes or no? This is equal to twice the number of edges. Okay, this is your number of edges. This we already know. Now, here we are putting the actual degrees, right? Yes or no? Tell me, here we are putting the actual degrees, like degree of V1 plus degree of V2 plus degree of Vn is equal to 2e. Do you agree? We are putting the actual degrees. Yes or no? We are putting the actual degrees. So what we are doing? We are putting the actual degree, actual degree, actual degree. We are putting the actual degrees. Now a simple question I am asking. In place of everything, if I put the minimum degree, if I put minimum degree, if I put minimum degree everywhere, if I put minimum degree everywhere, then what will happen to this equation? On which side this equation will, I can say, which side will be bigger? Which side will be larger? Are you getting my point? My point is very simple, that the total degree is equal to twice the number of edges. This is the total degree. This is twice the number of edges. Okay. So total degree, it simply means that for every vertex we are putting the actual degree. Every vertex we are putting the actual degree. For every vertex we are putting the actual degree. If I replace everything with minimum degree, then on which side will be bigger? So RHS will be bigger. Very good. Okay. Then RHS will be bigger. So I can say that RHS will be bigger. Very good. Okay. Now you tell me another simple question. If I replace everything with maximum degree, now which side will be bigger? I replace everything with maximum degree. Now which side will be bigger? Now you can notice that LHS will be bigger. Okay, LHS side will be bigger. If I replace everything with average degree, now tell me which side will be bigger? If I replace everything with average degree, now which side will be bigger? Which side will be bigger? Okay, now they will be same, right? Yes or no? Now they will be same. Now nothing will be bigger because you are replacing everything with average degree. Okay, so now nothing will change. Okay, everything you are replacing with average. So that will be 2e. That will be equal. Okay. Now now this is the question. So tell me the answer for this one. A simple question. You tell me. A graph is given to you, G, V, E. This graph, this satisfies this property. A property is satisfied by this graph. The minimum degree is defined like this. Minimum degree is the minimum of all the degrees. Okay, the minimum degree is minimum of all the degrees. That's correct. Okay, that's correct. So minimum degree of G cannot be. The question is saying that number of edges is less than or equal to 3 times number of vertices minus 6. Okay. The minimum degree is also given to you. Now the question is saying minimum degree cannot be. Okay. You tell me a simple thing. What is the total degree? You know the total degree, right? Okay. So you know the summation of all degrees. Like if I do summation of all degrees, that you already know. Summation of all degrees is twice the number of edges. So you tell me, if I replace everything with minimum degree multiplied by number of vertices, okay, that like for example this, yes or no? Like this is your number of vertices multiplied with the minimum degree. That will be this equation. Because if I replace everything with minimum degree, then RHS will be bigger. Okay. Similarly, if I replace everything with maximum degree, then LHS will be bigger. Okay. So these things we have already seen. These are very easy observations, very simple things. So you can notice, if I replace everything with minimum degree, if I replace every degree with minimum degree, then this equation I will get. Okay. RHS will be bigger. So you already know that if I replace every degree with minimum degree, then this RHS will be bigger, twice the number of edges. Okay. Twice the number of edges. I can also say that delta this divided by 2 is less than number of edges. And already number of edges is less than this. Already this is less than, this is already given to you. This is already given to you. So this equation ultimately we got this equation, correct? This equation we understood. So finally we have this equation that this divided by 2 is less than equal to 3 minus 6. Okay, so let me assume that this is equal to n. Number of vertices is equal to n. So from here I can say that n delta is less than equal to 6n minus 12. Okay. So now, so this is your equation. Now some options are already given to you. Okay. So can you say that, tell me a simple question. Can this delta be 6? Can this delta be 6? Like the question is saying the minimum degree cannot be. Minimum degree cannot be. Tell me, can it be 6? Let's try with 6. Can it be 6? Okay, so the question is very simple that now can it be 6? If I put delta equal to 6, then what will happen? Then you can notice 6n is less than equal to 6n minus 12. Is this correct? Is this correct? Never. This can never happen, right? Yes or no? This can never happen. That 6n, because n is number of vertices. N is a number of vertices. So number of vertices is always a natural number. Okay, remember this number of vertices, this n is a number of vertices. This is always natural number. So you cannot, this can never happen. So delta equal to 6 can never happen. Yes or no? It is never possible. Delta equal to 6 is never possible. Yeah, delta equal to 5 might be possible. Yes or no? Because this is the equation that we have. So delta equal to 5 might be possible. This might be possible. I don't know whether this is possible or not, but this might be possible because 5n is less than 6n minus 12. This is possible. This is possible. So very easily you can see that this delta equal to 6. This is never possible. This delta equal to 6. Okay. So tell me what is the answer? Minimum degree cannot be 6. Minimum degree cannot be 6. Minimum degree can be these. These are possible, but minimum degree can never be 6, because if minimum degree is 6, then you will get a contradiction. This equation can never be satisfied. This equation 6n is less than equal to 6n minus 12. This equation can never be satisfied. So this is your answer. For this question, the answer is option D. Very simple question. Let's see this question. Tell me the answer for this one. This is GATE 2013 question. Which of the following is true? The question is asking for true for undirected graph. Sum of degree is even. Of course, total degree is always even. Sum of degree of all vertices is even. Total degree is always even. Number of odd degree vertices is even. Both are correct. So both P, Q are correct. For this question, answer will be option C. Both are correct. Okay. So you can easily see, because remember total degree is always even and number of odd degree vertices is even. What about number of even degree vertices? What about number of even degree vertices? What about number of even degree vertices? What about that? Number of even degree vertices. What about that? That can be even or odd. Remember, that can be even or odd. That can be anything. That can be anything. Number of that can be anything. For example, consider this. Like consider this graph A, B, C, D. Okay. For example, like consider this. So you can notice this has 1, 1, 2. So now how many even degree vertices? Tell me how many even degree vertices? Tell me in this graph. Look at this graph and tell me how many even degree vertices. Look at this. How many even degree vertices in this graph? How many even degree vertices? So there is only one. There is only one even degree vertex. And if I do this, and for example, if I do this, now how many even degree vertices? Now every vertex has degree 3, 3, 3. So here you can notice, here number of even degree vertices was odd. Okay. Here also a number of even degree vertices is 0 actually. Okay. So here number of even degree vertices is 0. Here number of even degree vertices, that is odd. So here number of even degree vertices is even. So that can be even or odd. That can be anything. Okay. So that can be anything. Now let's see. What about this question? This is GATE 2017 question. What is the answer? GATE 2017 question, latest question. So tell me the answer. G is undirected graph with n vertices, 25 edges, such that each vertex has degree at least 3. What this line means? Can you tell me? What this line means? Anyone want to tell me what this line means? Each vertex of G has degree at least 3. Each vertex of G has degree at least 3. What this line means? This means that minimum degree is greater than 3. Minimum degree is greater than or equal to 3. Yes or no? Minimum degree is greater than or equal to 3. Okay. So the minimum degree will be greater than or equal to 3. Then the maximum possible value of n. The question is asking what is the maximum possible value of n. So again, you can easily solve this question. No, minimum degree is not 3. This line does not mean that minimum degree is 3. Okay, this line does not mean minimum degree is 3. Please understand. Please understand, this line does not mean that minimum degree is 3. This means minimum degree is at least 3. Okay. Now you tell me. So the answer will be what for this? There are 25 edges. Number of edges is also given to you, that is 25. That is number of edges. N is the number of vertices. This is the number of vertices. What is the maximum possible value of n? So you already know that total degree is what? If you do the degree summation of all vertices, that will be twice the number of edges. But if I decrease everything to minimum degree, like if I do minimum degree multiplied by n, then that will be what? That will be less than equal to 2e. Okay. So you can easily see that delta n is less than equal to 2e. Now it is also given that delta is greater than equal to 3. So tell me what about n delta? If you multiply by 3n is less than equal to n delta, right? Yes or no? This equation we have. So n delta is greater than 3n. So you can notice this n delta, this is greater than 3n. This n delta, this is greater than or equal to 3n. So this equation ultimately we got. This equation we got that 3n is less than equal to 2e. So n is less than equal to 50 divided by 3 because e is 25. So n is less than equal to 50 divided by 3, that is something like 16 something. You tell me, this is number of vertices. Can it be fraction? Can it be in fraction? Like can it be in fraction? Tell me. Can it be in like decimal like this? This is number of vertices, right? Number of vertices must be positive integer. Number of vertices. So this number of vertices must be positive integer. And this must be less than this. This must be less than equal to this. So the maximum value of n that is possible, maximum n will be equal to 16. This is the maximum n possible. Okay, maximum n that is possible is 16. In the GATE exam, this is a silly mistake which many students can do. What is the silly mistake people can do? Tell me. In this question, what is the silly mistake students can do? In this question, what is the silly mistake possible? The silly mistake possible is like if they put 16 point, like 16.66, something like that. If they point this is a silly mistake. This will be wrong. This will be wrong. This will be silly mistake because number of vertices must be a positive integer. This must be a positive integer. So this must be 16. Answer will be 16. So silly mistake is this, or another silly mistake is 17. Another silly mistake will be 17. Okay. Another silly mistake will be 17 because remember n is less than equal to this. Tell me, is 17 like this is a silly mistake. If you put n equal to 17, just think about it. If I put n equal to 17, is this correct? Is this equation making sense? Is this equation making sense? 17 is less than equal to 16 point something. No, this is not correct. Okay, so finally answer will be 16. This will be your answer. So for this question, the answer will be 16. Now let's see about directed graph. Let's quickly see about directed graph. Tell me, in the directed graph, tell me what is degree of this. Like if I give you a directed graph A, let me give you this directed graph. What is the degree of B? Tell me what is degree of B? Tell me what is degree of B? What is degree of B? Tell me. In the this is a directed graph. You can notice this is a directed graph. In this directed graph, what is the degree of B? Can you tell me? The answer is nonsense. The answer is nonsense. Here you can put the Jethalal meme, right? Nonsense. You know, so you can put that Jethalal meme you can put here. So this is nonsense. Why? Because for the directed graph, this degree word is not defined. Is this clear? This degree word is not defined. This word is not defined. So I cannot ask you this degree. This degree I cannot ask you. Okay, for a directed graph, this degree word is not defined. Okay, so this is nonsense. Now, you can simply say what is in degree, out degree. So what is defined then? What is defined? In degree, out degree is defined. Like what is in degree of B? In degree means how many incoming edges in B. How many incoming edges in B? How many incoming? So in degree of B will be 1. And what will be out degree of B? Out degree of B will be how many outgoing edges? How many outgoing edges? So outgoing edges is also 1. So tell me, actually let me tell you this in degree of B, how this is denoted. This is also denoted like B minus, and out degree is denoted at B plus. So B plus is 1 and B minus is 1. What is A minus? A minus means in degree. A minus means in degree. This means in degree of A. That is 0. There is no incoming edge. Okay. So what is out degree of A? Out degree of A is, that is 1 because there is outgoing edge. Similarly, for C, in degree is 1 and out degree is 0. So for the directed graph, we have in degree concept, we have out degree concept. These two concepts we have, in degree concept, out degree concept. Okay. So you can easily see, for example, if I give you this graph, now you tell me, let's assume you have self loop also. See, so tell me what is A plus, A minus? For every vertex you tell me what is A plus, what is A minus. Remember, A plus means out degree. What is out degree of A? A minus means that is in degree. What is in degree of A? Similarly, what is B plus, what is B minus? Similarly, what is C plus, what is C minus? Okay, so you quickly tell me. So you can notice that A plus means out degree. Okay, how? Okay, remember this self loop is like this. This self loop is like this. So because of self loop, 1 out degree, 1 in degree. Yes or no? Yes, agree or not? Do you agree or not? Because of this self loop you can understand like this. So because of this self loop, one out degree, 1 in degree. Okay, so out degree will be 1, 2, 3. Out degree will be 3. Okay, next in degree will be what? 1 in degree, 1 in degree this, 1 in degree this. So in degree will be 2. Okay, so out degree will be 3, in degree will be 2 for A. Okay, for B, what is out degree? Out degree is 2, in degree is 1. For C, out degree is 0, in degree is 2. Okay, so did you understand? For directed graph, we have this concept. So remember, if you have directed graph, if you have a directed graph, then there is no concept of degree. There is no concept of degree. This degree concept, this is nonsense. But in the GATE exam, they can define. Yes or no? Do you agree? Do you agree? They can define. Maybe they can give you some definition. But by default, this is nonsense. Okay? Nonsense by Jethalal. Okay. And for this, we have these concepts. Like we have in degree concept, in degree of a vertex V. This concept we have. And out degree concept we have. And out degree concept we have. So these concepts we have. Okay. Now let's move on. So very simple. In degree, out degree, all these concepts are there. Okay. A simple observation can you make? A simple observation. Tell me a simple observation. You know, there is a movie, Karan Arjun, and there is a dialogue. Agar Karan aaya to Arjun bhi aayega. Right? Yes or no? So there is a dialogue. There is a very famous dialogue in the Karan Arjun movie. Shahrukh Khan, Salman Khan. So similarly here also, tell me, agar in degree आई है तो out degree भी आएगी. Right? Yes or no? अगर in degree आई है, अगर in degree आई है तो out degree भी आएगी. Yes or no? So like what I'm saying, consider this graph, very important result, like important. So let's see a important result, or maybe that is already written here. Okay, so let's see a important result here. Okay, so yeah, so let's see this important result. Let me write an important result. What is this important result? This is like this. See, this important result, what is this result saying? This result is like this. Consider I am giving you a graph like A, B, C, D, E, something like this. This is a directed graph I will give you. Okay, I will give you a directed graph. And on this side I am writing total in degree. Okay, please understand. I am writing total in degree. What is the total in degree? Here I am writing what is the total out degree. And here I am writing number of edges. Number of edges. I am writing total in degree, total out degree, and number of edges. Okay. So now you tell me, if I put at this point of time, how many edges? At this point of time, how many edges? 0 edges. Total out degree, 0. Total in degree, 0. Now let me put one edge. Let me put this edge. Now you tell me how many edges? 1 edge. Total in degree. Total in degree is increasing by 1. Yes or no? Because of this edge. Because of this edge, total in degree will increase by 1. Okay. This total in degree, you can notice the in degree is increasing by 1 and out degree is increasing by 1. अगर in degree आई है तो out degree भी आएगी. Yes or no? अरे अगर in degree आई है तो किसी की out degree आएगी. B की in degree आई तो A की out degree आई. Yes or no? So in degree out degree these are like Karan Arjun. Okay, तो अगर in degree आई है तो out degree भी आएगी. Okay, basically अगर आप कहीं से कहीं जा रहे हो, मतलब अगर arrow आया तो मतलब अगर out degree आ रही है तो in degree भी आएगी. Very simple. Yes or no? If in degree is coming, then out degree is also coming. Yes or no? Very simple. So very easily you can notice this simple thing you can notice. If in degree is coming, then out degree is also coming. Now you tell me. So now you can notice the total out degree 1, total in degree 1. Now let me put another edge. Like consider this edge I am putting. Now you tell me. Now number of edges 2. Now again you can notice total in degree 2, total out degree 2. Okay, so and so on. Similarly, you can put any edge. For example, if I put this edge, self loop, then 3 edges, again total in degree, total out degree. So that will always increase and so on. So that will always be same. So finally, what I'm saying, let me tell you what I'm saying. I'm saying that if you have directed graph, then this will happen. In a directed graph, what will happen? This will happen that total in degree of this graph, total in degree of G will be equal to total out degree of G will be equal to number of edges. Will not be equal to twice the number of edges. That will be equal to number of edges. Okay, so that is going to be equal to number of edges. Number of edges. This is for directed graph. The reason is very simple. Because of every edge, in degree will increase by 1 and out degree will increase by 1. If you have two vertices, V, U, then because of every edge, total in degree will increase plus 1. Okay, this edge will increase. I can say total in degree will happen plus 1 and total out degree will happen plus 1 because of this edge. So that is the reason I can say number of edges is equal to total in degree is equal to total out degree. Okay, very simple. So that's your conclusion. So total in degree equal to total out degree is equal to number of edges. Okay. Now let's come back to simple graph. Remember, I told you most of the time which type of graph we study. Tell me. Most of the time, whenever I say graph, then which type of graph I want to say? I want to say about simple graph. Simple graph means undirected without self loop. Okay. Undirected graph without self loop, without multiple edges. Now let's see the concept of path, walk and cycle. What is the concept of path, walk and cycle? So this is very simple. Walk. What is walk? In any park, if you have some park, like in your society, if you have some park, then you do the walk, right? Yes or no? For example, this type of walking you do. This type of walking you can do. This type of walking. So this type of thing is called walk. Means consecutively you are walking. This type of thing is called walk. Okay. So in a walk, vertices and edges can repeat, correct? Whenever you are walking, tell me, do you repeat some point? Like for example, you are walking from here and like this. Can you repeat it? Of course you can repeat it, right? Yes or no? Of course you can repeat. You can repeat edge or vertex. Both of them you can repeat. So in a walk is just consecutive walking. It is very similar to consecutive walking. For example, this is a walk. From A you can go to C. From C you can go to A. From A you can go to C. So this is a walk. Okay, you are walking like this. Similarly, this is also a walk. You can go from A to C, then D. That's it. Okay, that's it. This is a walk. This is also a walk. Like from A, you can go to C, then you can go to D, then you can go to B, then you can go to A, then you can go to C, then you can go to A. This is also a walk. So all these things are walk. Okay. Now, what is a path? What is a path? So for example, in this graph, look at this graph, A, B, C, D. In this graph, you can notice that this is a path. If I ask you, what is the path from A to D? So what you will say? You will say that this is a path. That's it. This is a path. Okay, you will not say, will you say that, okay, sir, this is a path, sir, this is a path, sir, this is a path. No, what you will say? You will say just go like this, that's it. This is your path. So in a path, vertex edges do not repeat. Vertex edges, no repetition. Okay, vertex edges do not repeat. So in a path, these things do not repeat. Vertex and edges, these things do not repeat. Okay, so for example, this is not a path like A, B, A. This is not a path. Okay, for example, this is a path A, B, D, C. This is a path. This is also not a path A, B, D, C, A. This is also not a path. Okay, this is also not a path, because remember, vertices and edges cannot repeat. So in a path, vertices and edges, they do not repeat. They will never repeat. Okay, so this is the definition of path. Now let's see the next, that is cycle. What is cycle? cycle is basically path plus one more edge, that is initial and final vertex connected. Path plus close. Okay, means what it means? It must be combination of path plus close. Path plus close means, for example, if you have this type of thing is called cycle. A, B, C, and then like this. So this is called cycle. Remember, this is cycle. This is not a path. Remember, this is not a path. This is a cycle. Cycle means path and you close it, then it will become a cycle. So this is your cycle. And this is a convention that cycle always start with at least 3 vertices. Okay, this cycle, this concept we defined with at least 3 vertices. Okay, must have at least 3 vertices. Cycle must contain at least 3 vertices. This is a convention actually. Okay, what is length of a walk? Length of a walk is number of edges. So what is the length of a walk? That is number of edges in that walk. So for example, if you have this A, B, C, D, something like this. If you have this, then tell me, is this a walk? Is this a walk? Is this a walk? Tell me, is this a walk? From A to B, then from B to C. Is this a walk? This is not a walk. Yes or no? Array, this is not a walk. You are going here and then you are jumping out of nowhere. Okay, so this is not a walk. This A, B, C, this is not a walk. But you can notice that this is a walk. A, B, D, this is a walk. This is a walk. And what is the length? What is the length of this walk? For this walk, what is the length? The length is 2. And this is also a walk. Like you can go from A to B, then you can go to A, then you can go to B, then you can go to D, then you can go to C. This is a walk. What is the length? This is the walk. What is the length? The length is basically number of edges. 1, 2, 3, 4, 5. So number of edges. Okay, so the length will be 5. Similarly, number of edges is basically the length of walk, length of path. That is the concept. Also, please understand that this word cycle will always imply presence of at least 3 distinct edges. Okay, so this word we use, this word cycle, this we use, okay, when you have at least three edges. You must have at least 3 edges. So these are the cycles. Let me tell you, like these are the cycles. So for example, this is a cycle. For example, this is a cycle. For example, this is a cycle. So these type of things are cycle, and so on. Cycle, and so on. Okay, this is a cycle of length 3. This cycle has length 3. This number of edges, cycle has length 4. Number of edges, cycle has length 5. Okay, so these are your cycles. You can call it C3, you can call it C4, you can call it C5, and so on. Okay, so very simple. These are the concepts that we have seen